I want to look at where we were and why it was difficult. It was. We're looking at how the concept of the area under the curve came about, and then there was this problem that we already did. We did this example together. I have an earlier video for this. What it does is it says prove that for b for all b that is greater than 0, that's the interval right here. So it goes from 0 to b right here. So for all b that's greater than 0 of this, you get this formula. So what we did is we took the Riemann sum with n number of rectangles, and we wrote out what that was. And there's a sigma notation for that. And the reason why we did that is because we wanted to say what is the limit as we take n to infinity. Because if you took n to infinity, that would mean that you're taking you're trying to find what the value is when you have an infinite number of rectangles when you take it to infinity. Okay, and that would give you the area under the curve. So we'd take the limit as n goes to infinity of r sub n. So you're saying, like, if we have an infinite number of rectangles, and these are right endpoint rectangles, that's what the r means. But you can do it with left endpoints, and you can do it with midpoint, and you can do it the other way where it's not even a specified width of each rectangle. Okay, and all of what I said is really confusing if you don't understand any of what we did earlier. But I want you to see where we were and where we're going. So what we did with this is we simplified it, and then we got our formula, b to the third power divided by 3. This gives us the area under the x squared curve, starting at 0 and ending at some number. Okay, so here's the x squared curve. Whoa, that part doesn't look very curvy. Okay, here's the x squared curve. So it gives you this area right here. Okay, so then what we did is you had some problems that didn't give you a perfect interval to find. Because if it gave you a perfect interval, like if it said, all right, what is the area underneath this right here? So this b is now 5. And from 0 to 5, what is the area of this? Well, all you have to do is take the 5, take it to the third power, and divide it by 3, and that will give you your answer. Okay, and you'd be done. Because we found the formula for it. Then there's other problems that kind of took it a step farther. It said, well, what if you don't start at 0? What if you were trying to find the area under the curve from 4 to 7? Okay, of x squared dx. And so what does that mean? Let's look at my picture right here. We're going to say that this is 7, and we're going to say that this is 4. We need this right here. That's the answer it wants. That's what this wants right there. So how would you do that? And so since we know this formula, and that's the only way that we learned so far up to this point, then we would try to make this have this formula. Okay, and the formula is, in order to use this, you would have to go from 0, ugly integral, 0 to b and x squared dx. That's the only way you can use this formula, is if you have the integral going from 0 to b. Okay, you guys still with me? Yeah. Okay, so how can we split this up or manipulate this so that we can do this? Well, some of you guys might have thought right away that, oh, I can go from 0 to 7 x squared dx. But that doesn't give us the right area. That gives us too much. So what do we have to take away? We're going to take away what? From 0 to 4. Okay? Right? Right? So that's going to take away this green stuff right here, and then we're going to have an exact area under the curve. You guys still with me? Yeah. Okay. So then we use our formula, the formula that we found by using Riemann sums. Okay? So since we have from 0 to b, we have 0 to 7 here and 0 to 4, we can just plug that 7 and plug that 4 in, right? Okay, so we would have 7 to the third power divided by 3, and then you would have minus what would that be? 4 to the third power divided by 3. You guys see what's going on?
Yeah.
Okay, and then you would get your answer. Well, check it out. What we just did, this part right here, is the fundamental theorem of calculus. Okay, here, check this out. I'll write it right here. If we had, okay, this is golden right here, so I'm going to give it its own box. If you had an integral, like for, and I'm going to use the concrete numbers that we have. We have 4 to 7 of x squared dx. What would you do? This is what you would do. If you, I mean, we know a formula right here, but what if you didn't know the formula?
Take the antiderivative.
You would take the antiderivative. Now, did anybody notice that before they looked up anything? Okay, what's the antiderivative of x to the second power?
1/3 x.
It would be x to the third divided by 3, right? You would add 1 to the exponent, then divide it by that number. And so I just took the antiderivative of x squared. Now, normally the notation is written like this. After you take the antiderivative, you put a straight line right there, and you say you're going from 4 to 7. And that's just kind of to help you along, like so you don't lose your place. Don't take shortcuts. It's a good idea to write that down. And so the next thing you would do is you would take this, and you're going to plug in the 7 first, and you're going to subtract plugging in the 4. That's the fundamental theorem of calculus. Check it out. It would go 7 to the third power divided by 3, and then you would subtract, and you would do it again. You plug in the 4 this time. First we plug in the 7, next you plug in the 4. You always plug in the top one first, then you subtract and plug in the bottom one. And you get 3 to the third power divided by 3. And that's the same thing that we did right here. Oh, did I do something wrong? Oh, I put 3. Thank you. So that should be 4 to the third divided by 3. Plug that into a calculator to get your answer. So here it is, guys. The fundamental theorem of calculus. It says if you're going from A to B, remember our A was 4, and the B was 7, and you're going to take the antiderivative of f, which is why it says capital F right here. You're going to first plug in the B, the top one, and you're going to subtract the antiderivative with A plugged into it. There it is. So pretty. There's your fundamental theorem of calculus. I wanted to do a couple of problems just to practice, okay?